Okay, today we are in Chapter 4, Section 5, Simplify Square Roots, page 219. So today we are going to talk about the product property of square roots. So the word product, what operation does that mean? Product means?
Multiplication.
Everyone? Multiplication. So we're talking about multiplying square roots, okay? So let's see what that means. When we look at the square root of 36, we already know the answer. The square root of the principal root, the positive root of 36 is 6. You know that. Okay, so let's try it differently. Let's talk about the factors that make up 36. Are there any perfect square factors that make up 36? There are. What perfect square factors make up 36? 6 is not a perfect square, is it? So we can't use 6. What other factors does it have?
2.
2 is not a perfect square. Hannah. 9. 9 times what?
4.
9 times 4. Good. So we could write the square root of 36 as the square root of 9 times 4. Okay? And then watch this. We can actually pull this apart and say we have the square root of 9 times the square root of 4. The square root of 9, the square root of 9 is?
3.
Say it, 3. And the square root of 4 is? 2. And 3 times 2 is? 6. So you would never want to do this. You know that 36 has a square root of 6, right? But we are able to see the product property of square roots when we pull that number apart and we find the roots of its factors, right? Factors are terms you're multiplying together. Okay, so in the form of a rule, we're going to use variables, right? So how can you show the product property using square root of AB? How can we show the product property with that? Chris? Okay, so he's saying the square root of A times the square root of B. He said with the thingy over it, he means the radical, right?
Yeah.
And so we are taking the square root of A and the square root of B. The difference this time is we don't know what A or B are, right? So it's hard to change, to simplify this new expression, okay? A and B, though, must be greater than or equal to 0. Why must they be greater than or equal to 0, Nicholas?
Because then it has to be a whole number.
Okay, because then you can actually get an answer, right? Good. So you cannot find the root of a negative. And this is saying, let's allow A and B to be positive so we can actually find a real root rather than the complex numbers we were talking about earlier. Okay, so there are a couple of requirements to writing a radical expression in simplest form. How do we know a radical expression is in simplest form? When we look at the square root of 36, could we write that value in a more simple way? What is the square root of 36? 6. So is it easier to say, I want the square root of 36 basketballs at the court, or is it easier to say, I want 6 basketballs? 6. So it's simpler. Okay, so the first thing is, if you have a perfect square factor inside of the radical, you need to take it out. Okay? All perfect square factors, other than 1, need to be pulled out of the radical. And there's another rule for a simplest form radical. You are not to have fractions in the radical. You're not to have a radical in the denominator. So you may have a fraction that has a radical, but it has to be only in the numerator. We're going to see that in our samples coming up. Okay, so we're going to simplify radicals. We have the square root of 490. So the first thing we need to remember is we're not allowed to have perfect square factors in the radical. So can anyone see or give us the factors of 490, and maybe one of them is a perfect square?
I see 7.
You see a 7? So what factors make up 490? Lauren? Good. We could write this as 49 times 10, right? 49 times 10. And as we saw with the product property, we could even write this as the square root of 49 times the square root of 10. And that's where Ryan saw 7, right? The square root of 49 is? 7. So the question is, does the square root of 10 have any perfect square factors in it? What are the factors of 10? We have 1 times 10, so there's your 1, but 1 will always be a factor of any number, right? So we're not going to simplify anything by writing 1 times 10. The other factors are, Dylan?
2, 5.
2 times 5. Are either of those perfect square factors? 2, square root of 2, square root of 5? No. So we leave the square root of 10 as it is because it is simplified. Now, could we find a approximate value of the square root of 10? Can somebody give me what you think is the approximate value of the square root of 10? Dylan? 3.3 repeating? That's reasonable, isn't it? Or 3.1 or 2? I mean, it's something small because 10 is close to 9. It's a little bit bigger than the square root of 9, which is 3. But when we're asked just to simplify the radical, you're not going to give the value. You're going to just leave a radical in your answer as long as it's simplified. Okay? Let's try this next one. Yes? The square root of 112. It's not as clear as the square root of 490, right? Where we saw 49 jumping out at us. This one I don't see a perfect square jumping out at us. But can we find factors of square root of 112? What goes into 112? Wesley? Okay, 2 times what? It says 51, but 51 times 2 would be 102, I think, wouldn't it? 2 goes into the 11 5 times, right? But then I have 12 left. So 2 goes into, good, 56, okay? So are 2 or 56 perfect square factors? No, so we're going to have to keep factoring to see if there are any squares in here. Okay? So how could we factor 56? What is in 56? Lauren? Say it again? Oh, I was talking to this Lauren. Okay, we can say 8 times 7. Are 8 or 7 perfect squares? Are they? No. 8 or 7? No, they're not. Lauren, what were you going to say? Or can you give me another factor? Can either of these be factored?
2 times 4.
Okay, so now look at this. We've broken this down to almost the prime factors. Do you see a perfect square factor now? Do you see it? Which of these numbers can we find the perfect square of? Everyone? 4, right? And so what we're going to do is we're going to take the square root of 4 and pull it out of the radical. The square root of 4 is 2, so let's pull it out. Okay? Does anyone see another perfect square? What is the square root of 4, Riley? So we took it out, right? We took the square root of 4 out. And do you see this? What is 2 times 2?
4.
Can we take that out as well? What's the square root of 4 again? 2. So we have another 2 that we can take out. See that? And so that means really we have 2 times 2 out of the radical. 2 times 2 is 4. And then we have the square root of 7 remaining in the radical. We can't take that root. It's an irrational number. So look at back up here where we had 2 times 2 times 4. What is 2 times 2 times 4? Say it? 16. So there was this large perfect square 16. We ended up getting it out, right? But we didn't see it in 112. No one here said 16 can go into that number. We just didn't know that, right? But we discovered it by factoring 112, okay? Kind of tricky. Okay, let's try simplifying the square root of 245b. So you might want to pause the video and try to factor 245 and look for perfect square factors, right? So, does anyone see a factor in 245? What would you pull out, Rachel?
5.
Okay, so we would say 245 is 5 times, 5 goes into 24, 4 times, and then 45,
8.
9 times, 5 times 9, right? Times b. So these are the factors in 245b. Are any of these perfect square factors?
Yes.
Which one?
49.
So what is the square root of 49?
7.
Okay, so we're going to take the square root of 49 out and call it 7, right? Are there any other perfect square factors in the radical? No. So what will we do? Leave them in the radical. They're not perfect squares. So your answer is 7 times the square root of 5b. Now, if somebody tells me that b is 9, we can pull that out, right? Square root of 9 is 3. We would pull it out here, but we don't know what b is, so it stays in. Okay? Okay, so let's simplify a product of two radicals. So square root of 18 times the square root of 27. How could we write that differently using our product property? Rachel?
18 times 27.
All inside the radical, right? 18 times 27. So just as we could pull the factors out apart in a radical, we can actually combine them into a radical. They both have a radical, so they can both be put inside of the same radical. And now we're looking for perfect squares, right? So what factors do 18 and 27 have in common? 9, right? So we could write 18 as 2 times 9 and 27 as 9 times what? 3. Good. Okay, so what do we have? What is this large perfect square factor in the radical here? Do you see it? Lauren?
9 times 9.
Good. 9 times 9 is what? This is 81, right? So we're going to pull out the square root of 81, and the square root of 81 is 9, right? We have 9, and then inside the radical, 2 times 3. Are 2 and 3 in either of those perfect squares? No. So how can we write that more simply then? Instead of 2 times 3, we can write that as 6. We can leave it as 6 because it doesn't have perfect square factors. So simplify these 3 radicals. Okay, so take a moment to review the beautiful work done by 7M. Excellent answers here. You may pause the video if you need to. If you're ready, we're ready to go on. And try using the product property with expressions that aren't fully simplified. See that? So we're going to pause the video again and work through these and simplify these radicals. Okay, so this is the, I forget, who did number 4? Sterling's beautiful work on number 4. She found the square root of 4 could be taken, and we have 2 times the square root of 3. Very good. And who did number 5? Nick. He found that when you combine the square root of 3 times the square root of 6, we end up with the square root of 9. And he pulled a 3 out and left the square root of 2 in. And then we just had this beautiful work by Liam. He found that we had a square root of 16 inside the radical, so he pulled out 4. The square root of 16 is 4. And we have the square root of 6 left in the radical. What's the operation between 2 and the square root of 3? Does anyone know? Say it loud. Multiplication. Good. And 3, this is 3 times the square root of 2. And this is 4 times the square root of 6. Just in case you are ever asked, that's what that is. Okay, you may begin your assignment. Good job, 7M.